In this lesson, we are going to talk about transformations of quadratic functions. So before we start with this lesson, I want to make sure that you have opened the link provided to get to Desmos. So when you have that extra tab open, it should look something like this. And we are going to be going back and forth between Desmos and your video, okay? So there will be several times where I ask you to pause the video, or the video will pause on its own, and I want you to go to Desmos and explore a little bit. We've picked this specific set here for you to look at because this is going to show you transformations. So the very first thing that I want you to notice in Desmos is this formula up here. This is vertex form of a quadratic function. So if we go to your notes, I want you to write that the vertex form of a quadratic function, so y equals, or f of x equals a, oops, parentheses, x minus h squared plus k. Remember that your vertex, of course, was always that h and k value. And a, if you think back to when we have done absolute value functions, a was always our slope in both directions. So the a value in a quadratic function doesn't necessarily reference slope, but it does have to do with your rate of change. Okay, so your a value is similar to your rate of change. It's not going to be exact because a quadratic function doesn't have a constant rate of change, but you can get an idea specifically whether or not there is a stretch or a compression. And also whether or not there is a reflection. So all of that can be seen from your a value. So now what I want you to do is go to Desmos, and I want you to, let me put this back in the right spot for you. These little sliders here help you change your a, h, and k values so that you can kind of explore what happens as those values change. So let's just leave our vertex here at 0, 0, but I want you to take the slider for your a value and just kind of move it and pay attention to what happens to that value as well as what happens to your picture. Now notice here that these big lines are all 2. So I've got 2 or negative 2, up 2 or down 2. And so like if you wanted to move 1, that would be this middle light gray line. Each of these lines are half. I hope that makes sense for you. So I just want you to drag your slider around and check out what happens with your picture. And I want you to think about it for a moment before I tell you what you should be seeing. I want you to be looking, what do you notice is happening as this value gets larger? What happens to the picture? Or as that value gets smaller, what happens to your picture? What happens to your picture when it becomes negative and still small to large? Okay, so hopefully you have paused the video and taken a look at that and come up with some answers on your own as to what happens here. But what I want you to see, let's focus on when this is positive. So a is 1 is the typical or parent function here. So if I have my vertex is at 0, 0, which my h and k values are 0, 0, and then my a value is 1, this would be our parent function, y equals x squared. So as you can see here, it's sitting right at the origin, and if I look, to get to each of my first points is going to be up 1 over 1, up 1 over 1 to get to each of those first points. Okay, let's take a look at what happens when I switch that a value up 1 to 2. What happened to that picture? It got a little narrower, right? So now I'm going, instead of up 1 over 1, I'm going up 2 over 1 in both directions. We call this a vertical stretch. It's kind of like I'm pulling the top and I'm just stretching it upwards. It's going to make your picture more narrow overall. And so if I keep going and I make that value 3, now I'm going up 3 over 1. Do you agree that it's just making it more and more narrow? And so the larger my A value gets, the more and more narrow my picture is becoming. Do you see that? It's getting more and more narrow. And here I have all the way up to 10. And that's a pretty narrow look. Remember that this is a vertical stretch. So I want it to, back to your notes. Okay, and when I want you to make some sort of note here that a vertical stretch is when your A value is greater than 1. So then what do you think about this compression? What do you think is going to happen with a compression? Let's go back here and let's look. So we talked about when A is greater than 1. Let's talk about when A is less than 1. So I want to keep this positive, so I'm still going to stay above 0 for the moment. We haven't talked about that yet. But let's look at what happens as I make this smaller. Let's say I go to 1/2, which would be 0.5. What do you notice happened with our picture from 1 to 0.5? Do you notice that this shape got a little wider? So our parent function was up 1 over 1, but now I'm going up 1/2 and over 2 to get to my first point. I'm sorry, over 1. So, or I'm going up, up 1/2 and over 1 versus up 1 over 1. And if I keep going smaller and I get closer and closer to 0, do you notice how that picture keeps getting wider? Look how wide that one is right there. I'm almost to 0, and it's really widened out, right? This is called a compression. It's kind of as if, think about if you had like a rubber band and you were to compress from the top. If compress means to push or put pressure on. And so if I were to push down on that rubber band, it would widen it out. Versus if I were to pull and stretch that rubber band up, it would really make it really skinny. Or narrow. So we are looking here that when we take our A value less than 0, or if I make it a fraction, that's going to cause a compression. So let's go back to our notes and let's make a note that a compression is when your A value is less than 1. However, do you notice that these are still positive? Okay. Signs don't matter when you're talking about a stretch or compression because a sign actually has more to do with reflection. So let's look at our A value and now let's make it negative. Now, as soon as I make it negative, what do you notice happens? It flips, right? It is going to reflect across that vertex or reflect over, in this case, the x-axis. So now it's upside down, but notice I'm still at a decimal. And look what happens as I get closer to that -1. So again, I am at -1. And if I make that value of the number, regardless of the sign, so it's like we're taking the absolute value of that A value, we are getting a more narrow picture again, right? It's just that it's negative, but it's going to be the same. So take a look at this. I have A is -8. Let's go and jump to where A is +8. It is the same picture except that we flipped it. You see that? Go back to -8. It is the same picture. So that stretch and compress has to do with the absolute value of your A value, okay? Because, again, the sign is going to flip it over that axis. So your reflection is if you have a negative in your A value, that's going to give you a reflection, okay? So these are things that you are going to just kind of need to memorize, and we're going to practice a little bit. But when it comes to the stretch and compression and reflection, all of those things can be found from your A value. Whether or not your A value is a number larger than 1, or if it's a fraction, or if it's negative, all of those things come from that A value in your function. Okay? So then we have our H value. Let's go look at what happens with our H value. So I'm going to reset this back to 1, because that again is our parent function. Oops, too far. And I'm going to take my H value and I'm going to play with that slider. So I want you to take a moment, pause the video or let it pause for you, and just move your H value and see what happens. So if we go back to your notes for a moment, your H value here has to do with your vertex, right? It is the horizontal movement of the vertex. We could also say that this is a horizontal shift. Now, horizontal, remember, means from left to right. So if you are looking at your H value, as I'm moving to a positive value of H, see that? It is moving more and more to the right. As I am moving more and more to the left, so I make my H value negative, I am moving more and more to the left. Okay, so your H value will change left to right. Now, one thing that you have to remember about your H value is that your formula is a negative. Okay, so if your H value is actually a positive 3, you're shifting to the right, it's actually going to say negative 3 up here. So just remember that the formula has a negative and you want to change that sign. Just like when we find the vertex. You guys have found the vertex before from an equation. We talked about that in 7.4 and 7.2 where it lies to you inside. Do you remember that? Same idea. Okay, if you're looking here and it says -3, your transformation would actually be a positive 3, which means we're moving to the right 3. So be careful of that. You might want to make a note. Okay, last thing we got to talk about is your K value. So I'm going to reset my H value to 0, and now let's look at the K value. Take a moment to explore with the slider here and see what you think you could describe this transformation as. As you can see, as I move my slider up, or my number becomes more positive, it's going to shift up. And as my number is more negative, it's going to shift down. So this is called a vertical shift. And so very similar to the H value, it is just going to move vertically instead. So this is going to be your vertical movement of the vertex, or we could call it a vertical shift. And this time, you know, in the formula, it's a plus K. So it's not going to lie to you. This one actually tells the truth. If it says +3, you're moving up 3. If it says -5, you're moving down 5. So just think about what positive, negative means, and this one you keep that value. So let's go ahead and look at what some of your questions are going to look like. So in example 1, it says describe the transformation from f of x equals x squared to g of x equals x plus 7 squared minus 6. So if we look, always start with your A value. And in this case, do we have an A value? No, in this case, A is going to equal 1. No idea why my colors changed. But A is 1, and that's normal. So there's no transformation there. So I don't have to worry about a vertical shift or compression or a reflection. So let's go look at our H and K values. So this would be your H value, and here would be your K value. So remember that H is a horizontal shift, right? So my H value here is +7, but remember that the H value lies to you. So we're actually thinking about a -7. And if this is a -7, would we be shifting left or right? So if you need to remind yourself, you can go back to Desmos and go change your h value to a negative. And which direction are we moving when we talk about negative? I'm moving to the left. So we are going to say that this transformation is a shift. We're going to start with our horizontal, and we're going to say left 7. And then what about our k value? What kind of transformation does that k value make? Well, if you look back, k value is always a vertical shift, and it doesn't lie to you, right? So if this says -6, are we moving up or down? It's negative, so we're moving down. So we're just going to add and down 6. And again, I have no idea why the colors keep changing. Sorry about that. So here we have our answer. We're describing, that means we're using words. So I need to say that we are shifting left 7 and down 6. Cool, let's try the next one. So again, always start by checking for that a value. And in this case, again, we don't have anything here for an a value, which means that a is 1, which is normal. Okay, that's our parent function. There is no stretch or compression or reflection. So then we're going to go look at our shifts. Okay, I have an h and k value. So we know we are going to be shifting. Now this -4 means that my h value is actually what? A +4. And when you think about a +4, are we shifting left or right? +4 means we're going to shift to the right. You can always go back to Desmos and double check. So we're going right 4 and our k value. Is our k value going to be positive or -2? It is a +2. And so if we are at a +2 for our k value, where are we going to be shifting? We're going to shift up. If it's positive, 2. And that's it. We're shifting right 4 and up 2. Now in example 3, again, first start by double checking with your a value. And this time our a value is 2. If your a value is 2, is that going to be a stretch or a compression? Well, this a value is larger than 1. 2 is greater than 1. So that means that this is going to be a stretch or a vertical stretch. So I'm going to write that this is a vertical stretch. But we also have an h value. If you notice, it's in the parentheses, so that is an h value. So if this is an h value, would my h value be positive or -1? It is a -1 because it lies to you in those parentheses, right? So if it's a -1, are we going to be shifting left, right, up, down? We're talking about our h value, so it has to be left or right, and our h value is negative, which means we are going to be moving to the left. So I have a vertical stretch, and we are going to shift left 1. Now if you notice, we don't have a k value here. Okay, there's nothing on the outside, so I don't have to worry about transforming my k value. I don't have to move anywhere up or down. So our description here in words is that we have a vertical stretch and we are shifting left 1. Let's look at example 4. So example 4, again, we're looking at that a value. Now I see two things. I see a fraction. Is a fraction greater than or less than 1? It's definitely less than 1, which means would that be a stretch or a compression? It's a compression. Anything less than 1 is a compression, so we definitely have a compression. But I also notice that we have that negative right there. And so what does a negative mean? A negative means that it's reflecting, right? If we look back to Desmos and I move that down into the negatives, it is reflecting. Let's move our stuff back up. So do you see how it flips down and it reflects over the vertex? It was up at positive, now it's down at a negative. So it is a reflection. So then we want to check our h and k values. So I do have both h and k here. And so for my h value, what is my h value? H is going to equal a positive 2. And if it equals a positive 2, are we shifting up, down, left, or right? Well, h values are always left or right. And this is a positive, which means it's going to be to the right. So we are shifting right. And then we want to look at our k value. So in this case, k is going to equal what? Negative 1. And so if h is our left, right, that means k is up or down. And so are we going to be shifting up 1 or down 1? We are definitely shifting down 1 because it's negative, and negatives are always down. Okay, so now let's talk about if it's going to, if they give you the transformation and they want the equation. So in this case, they're asking you for the equation of the function that results from the transformation of x squared. So they're giving you these transformations down here. So always start with writing your function, either y equals or f of x equals or whatever it might tell you. In this case, it doesn't matter. So then let's look. We are reflecting, and then we are shifting. So let's start with this reflection. Which value does a reflection deal with? It's your a value. And what it means is that a reflection has to make it negative. So I'm definitely going to have a negative for my a value. And then we'll open those parentheses, and we're talking about shifting left 3. Now left makes your h value a negative, so our h value is going to be a negative 3. But remember, in those parentheses, it lies to you, right? So instead of saying h minus 3, because it lies, we have to say plus 3. So I'm going to say x plus 3, because then I would pull out that negative 3 as my h value. But then we have our k value would be up 2. So k is going to equal 2. Do I need to change that when I put it in my equation? No. So I'm just going to say plus 2. And that would be my equation. Let's try another one. So we're writing the equation of the function that results from the transformation of x squared. So we have here a compression, and we're shifting up 4, so a compression. What value, a, h, or k, is a compression? It's your a, so we know that our a value is going to equal 1/4. But then, if we are shifting up 4, which value is that? It's our k value. So I'm going to start with my y equals. I'm going to start with my a value of 1/4. Open my parentheses. Do I have an h value? Nope. But I do have a k value. So if my k value is positive 4, do I need a plus 4 or minus 4? It will be a plus 4 because your k value does not lie. It tells the truth. And that would be my equation. This one could also be written as y equals 1/4 x squared plus 4 without the parentheses. The parentheses would be implied at that point. So this one, if we are, again, wanting to write that equation, we're talking about a reflection and a stretch. Both of these deal with which value? Your a value. So reflect means my a value is going to be negative, but it's a stretch by 2, so it would be a negative 2. Now remember, we're transforming this x squared. So if I don't have an h or k value, both of those would be 0, so I can actually just leave this x squared. So I can say y equals a negative 2 x squared. And again, you can always go back to Desmos and check that. If I have my h and k values would be 0 because that's where we start. So my vertex is right there. And then I just want to shift this to a -2 if we were to start at 1. Here's 1. I want to reflect it, so that makes it negative. And then I want to stretch it to -2. So that would make my -2x squared. Last one. This time I don't have any stretch, reflection, or compression. I'm just shifting left or right. So I'm going to start with my y equals. If I'm going right 6, which value does that change? It makes your h value a +6. Whoops. But if we are talking about in my equation, do I want to say x plus 6 or x minus 6? Remember, the h value lies to you in the equation, and so if h is actually a positive, we are going to write it as a negative in the equation. And then I have this down 4, so which value is that? That is k equals 4. So in my equation, do I want to write that as +4 or -4? It's going to be a +4. And that's my equation. So hopefully you have kind of picked up on how this works. Go ahead and try some of your practice.